Okay, this is case 3 of decomposing P over Q, where Q has non-repeated irreducible quadratic factor. And these are the first 6 problems that I found. I don't know if I'll get to all of those, but we're going to do as much as we can to go to 20 minutes about. So the first one is 15, and let's look at it so we know what this irreducible, non-repeated, irreducible quadratic factor means. Basically, it means that you see this factor here, x squared plus 1, we can't reduce it. Now, notice that this is a linear factor. So you can have a linear factor with your irreducible quadratic factors, but it gets bumped up to case 3, because if it gets bumped up, then you have to call this case 3. When it's case 3, what you have to do is notice that we have to write our unknowns in this form in a linear fashion. Because if we have a B, say, is 1 and C is 2, that would be x plus 2. This is still called a proper rational expression. So this could be what we need to get back. Remember what our goal is, to get back to our original. So we're trying to decompose it. We might not have a B, we might not have a C, but we have to set it up just in case we do. Now we're going to do the same steps as we did before, is clear the fractions. So you multiply everything through by your LCD, and you multiply by LCD, you're going to get 1 equals A times x squared plus 1 plus BC plus C times x. Now, what I think I'm going to do first is let's let x be 0. If we let x be 0, what will happen here? If I let x be 0, if this x is 0, it knocks out this whole thing here. So I'm going to just let 1 equals A times 0 plus 1. I'll go ahead and put the zeros in. And what happens here, the 0 just knocks that whole thing out. So we can solve for A. So we have A equals 1. And that's nice to know. But I'm not sure what to do with B and C. So I'm going to go ahead and try and let x be 1. And you can just pick whatever you want. I'm going to let x be 1. And again, you should be writing all this down. So let's let x be 1. Let x equal 1. We're going to get 1 equals A times 1 squared plus 1 plus B times 1 plus C times 1. The reason I like 1 is because it makes it simpler. So we get 1 equals 2A plus B plus C. Now I already know what A is. I forgot, but A is 1. So I'm going to plug in 1. So I get 1 equals 2 plus B plus C. So we have basically B plus C equals negative 1. Okay? Now, let's do it again. Let's let x be negative 1. And do the same thing. In this case, we get 1 equals A times negative 1 squared plus 1 plus B times negative 1 plus C times negative 1. In this case, we're going to get 1 equals, this part equals 2, so that's 2A. And we're going to get plus B minus C. Basically, this is negative B times negative 1 is positive, and then we just negate the C. Now, in this case, A we already know is 1, so we have 1 equals 2 plus B minus C. In this case, we have B minus C equals negative 1. And we're trying to solve for B and C, so we have two equations. We have a system of linear equations. We have B plus C equals negative 1, and b minus c equal negative 1. So we have b plus c equal negative 1. Erase that, negative 1. And we have b minus c equal negative 1. So when you do a system of equations, we're going to add. So this is 2b equals negative 2. So b equals negative 1. If I plug back b into either one of these, let's say this negative 1, I plug negative 1 here, and clearly that means c is what? 0. So when I rewrite my equation, what I get is 1 over x times x squared plus 1 equals 1, which was my a over x, plus, and remember what we had here, we had bx plus c over x squared plus 1. Well, my b is negative 1, so I'm going to change my b to negative 1, and my c was 0, so I really didn't have a 0, so I just make that 0, and I get 1 over x plus negative x over x squared plus 1. We didn't know that we wouldn't have a c here, but we had to set it up to make sure, just in case we did have a c. And that is your answer right here. That goes to that. Okay, let's try 16. 16, we have 1 over x plus 1 times x squared plus 4. By the way, these are really good quiz questions, these right here. X plus 1 plus bx plus c over x squared plus 4. I'm going to clear my fractions. Just multiply everything through by your LCD. And you're going to get 1 equals a times x squared plus 4 plus bx plus c times x plus 1. Now clearly what I'm going to do is let x be negative 1. So let x be negative 1, what happens here? This is going to be 0, and whatever this is, it's going to 0 it out. So I'm going to go ahead and let x be negative 1, and I get 1 equals a times negative 1 squared plus 4. So we get 5a equals 1, so a is 1/5. Now, this is the harder part. So we have our a, just remember it's 1/5, and we're going to do, let's let x be 1 and see what happens there. And we have to do the system of equations again. So we're going to let x be 1, just because it's easy, and I'm going to get 1 equals 5a plus, or let's just do the whole thing. 1 equals a times 1 squared plus 4 plus b times 1 plus c times 1 plus 1. Alright, because remember this is x plus 1 here. So when you clean it up, you're going to get 1 equals 5a plus b plus c times 2. We already know a is 1/5, so when you plug in 1/5 here, you're going to get 1. So you get 1 equals 1 plus 2b plus 2c. Solve for b and c, so we're going to get 2, or actually we get 0 here. We're going to get 0 equals 2b plus 2c. Alright? Now let's go ahead and try, let's try letting x be 0. You can pick anything you want, but I'm going to go ahead and, I'm trying to pick the easiest ones that happen. So letting let x be 0, so you're going to get 1 equals a times 0 squared plus 4 plus b times 0. That knocks out my b, doesn't it? Plus c times 0 plus 1. In this case, I get 1 equals 4a plus c. We already know that a is 1/5, so you get 1 equals 4/5 plus c. So clearly, when you subtract 4/5, this is like 5/5 minus 4/5, equals C, so C equals 1/5. So we have our A and our C, and we already know that if I factor this out here, I know that B plus C equals 0. So I have 0 equals B plus C. And C we know is 1/5. So we get 1/5. Actually, C is 1/5. So we have B plus 1/5 equals 0. So we know that B is negative is 1/5. Should be negative. Yeah, negative 1/5. Because negative 1/5 plus 1/5 is 0. And then when you write out your equation, you're going to get, and I'm just going to write it out, just the decomp part. You just write it just like that. Okay? And this is not an equals. What is this? This is a plus. Okay, so that's your decomp part. Alright, the next one I found was 21. Let's look at 21, see if it's any scarier. They get harder, you know. So 21, yeah, a little harder. Let's do 21. I'll probably get 2 more done here. So basically, I'm going to go ahead and start 21 here because we're going to have to factor. We have 1 over x cubed minus 8. Now, by now, you should already know this is really 1 over x minus 2 times x squared plus 2x plus 4. Alright? This is a linear factor. This is an irreducible quadratic factor. So basically what you're going to be doing is 1 over x cubed minus 8 equals a over x minus 2 plus b x plus c over x squared plus 2x plus 4. Alright, and then we're going to clear the fractions. When you clear the fractions, you're going to get 1 equals a times x squared plus 2x plus 4 plus bx plus c times x minus 2. Alright? Now the first thing I want to do is let x be 2, because if I let x be 2 here, that zeroes this whole thing out. So I want x be 2. Everywhere there's an x, I put 2. So we get 12a equals 1. So a is 1/12. Now I'm going to go ahead and try and let x be 0. I'll write it in here. Let x be 0. I'm going to get 1 equals 4a plus, I'm going to go ahead and write this out, b times 0, that's going to knock out. So it's just going to be c times negative 2. Because the 0 is going to knock out the b there. So we get 1 equals 4 times whatever my a is, minus 2c. And my a was what? 1/12? So 1 equals 4, this is going to be 1/3 minus 2c. So 3/3 minus 1/3 is 2/3. So we get 2/3 equals negative 2c. You divide both sides by negative 2, you're going to get c equals negative 2 over 6, which equals negative 1 over 3. So we now know what a is, and we know what c is, and we have to find b. So to find b, we're going ahead and try to let x equal 1. So we get 1 equals a times 1 squared plus 2 times 1 plus 4 plus b times 1 plus c times 1 minus 2. So this yields 1 equals 7a minus b minus c. I'm just going to plug in my b and a and c, and I'm going to get 1 equals 7 times 1/12 minus b minus a negative 1/3. So I get b, I'll move the b over here. So b is going to equal 7/12 plus 1/3 minus 1, and that all equals 1/12. So our final answer will be a 1/12 over x minus 2 plus negative 1/12 x minus 1/3. You can write it that way, over x squared plus 2x plus 4. Or you can write it this way, 1/12 over x minus 2 plus negative 1/12 over x plus 4 times x plus 4 over x squared plus 2x plus 4. Alright, that's just using the greatest common factor. Alright, now, I think we only have time for one more, so it's either going to be 22, 27, or 29. Let me look at 27. That's pretty long. We can do that one in class. You can understand where you're going to have to do some of these at home because we only have slotted 2 days for this. And 29 is not so bad. But let's go ahead and do 22. And that should take care of our minutes here. And that just gets you started. So we have 22. We have 2x plus 4 over x cubed minus 1. So we're going to set this to a over x minus 1 plus bx plus c, and I'm just factoring this right here, which you know is x squared plus x plus 1. Clear the fractions. You're going to get 2x plus 4 equals a times x squared plus x plus 1 plus bx plus c times x minus 1. Right, the first thing I'm going to do is let x be 1. When I do that, I'm going to get 2 times 1 plus 4 equals, you know this is going to knock out here, right? So we're just going to get 1 plus 1 plus 1 is 3, so 3a. And that's going to give us, this equals what, 6? Okay, so 6 equals 3a. So a equals 2. So we have a. Now we have to find b and c. So just remember, have this written down so we can move on. The next one we're going to do is let x be negative 1. And let's go for that. Or you could do 0. Let's go ahead and try. Let's do 0. I just want to do 0. It looks easier. So I put in 0 here. It makes it not so complicated. So when we do 0, we're going to get 2 times 0 plus 4 equals a times 0 plus 0 plus 1. So that's just times 1 plus b times 0 plus c times 0 minus 1. The reason I wanted to use 0 is because that knocks that out. And we can find that later using the system of equations if we have to. So we're going to get 4 equals a minus c. Because this just equals negative 1. Negative 1 times c. Now, we already know what a is. A is 2, so let's plug in 2. So 4 equals 2 minus c. Therefore, c has to be negative 2. Because if you subtract 2 from both sides, or I just did it in my head, you have 2 equals negative c. So c equals negative 2. So we basically have a equals 2 and c equals negative 2. And we need one more. So let's try the negative 1 now. We're going to let x equal -1. So you have 2 times -1 plus 4 equals a times -1 squared plus -1 plus 1 plus b times -1 plus c times -1 minus 1. Alright, looks fun. This is -2. This is going to be negative b. What does this all equal? This all equals, this cancels, so we're just going to get a again. So, and this equals what? 2. So 2 equals 1a plus, what's the b going to be? This is -2 here, so that's going to be plus 2b minus 2c. Alright? Now, we know what a is. A is 2. So we have 2 equals 2 plus 2b, and we know what c is what? -2. So we're going to get 2b equals -4, so b is -2. Therefore, our final equation is 2x plus 4 over x cubed minus 1 equals 2 over x minus 1 plus -2x minus 2 over x squared plus x plus 1, where this was my a, this was my b, and this was my c. And that's all of this one. The next one's going to be repeated quadratic factors. You can imagine these are going to be harder.